In this lecture, I'd like to introduce you to a new symbol and a couple of rules accompanying that symbol. Our new symbol will be a symbol for the sentential connective OR, which we'll represent with this little V symbol here, which I've typed using the lowercase letter v. Suppose, for example, that we want to symbolize the sentence, "A Democrat will win the next election," or "A Republican will win the next election." And we let P abbreviate "A Democrat will win the next election," and we let Q abbreviate "A Republican will win the next election." If we have those abbreviations, then we would symbolize this sentence above, "A Democrat will win the next election," or "A Republican will win the next election," as follows. P, this V symbol, Q. Okay, that's pretty straightforward. That's our symbol for OR. Let's go ahead and discuss a couple of rules for using that symbol. So our first rule is the rule of disjunction introduction. It may be stated as follows. Whenever one has a sentence on a line, one may write down a new line containing the disjunction of that sentence with whichever sentence one pleases, with those sentences occurring in whichever order one pleases. So let's go ahead and look at an example of an application of the rule. We have the sequent P, therefore P or Q. To prove the validity of this sequent, we start out by writing down our premise. Now that we've done that, we may use the rule of disjunction introduction to infer from our premise P or Q. Here's another example. P, therefore Q or P. Again, we start down by writing down our sentence, and the rule of disjunction introduction allows us to infer Q or P. So what this pair of examples illustrates is that the rule of disjunction introduction allows us to infer the disjunction of any sentence we already have with any arbitrary sentence, and the order of the disjunction that we write down doesn't matter. So we were allowed to use the rule of disjunction introduction to infer from P, P or Q. We are also allowed to infer from P, Q or P. Now this rule might seem a little odd. It might seem a little odd that we're allowed to just take a sentence and then write down the disjunction of that sentence with any arbitrary sentence. But once we understand the kind of OR that we're working with here, the rule is actually a self-evidently valid rule. The kind of OR that we're working with here is an inclusive OR. Disjunctions that make use of an inclusive OR are true just in case at least one, and maybe both, of the disjuncts is true. So from the fact that the sky is blue, one may infer that the sky is blue or the grass is green. And from the fact that the sky is blue, one may infer that the sky is blue or the moon is made of cheese. Now, of course, it's false that the moon is made of cheese, but that doesn't matter as far as the truth of the disjunction, the sky is blue or the moon is made of cheese, is concerned. All that matters is that at least one of the disjuncts is true. So given this understanding of what OR means, the rule of disjunction introduction is self-evidently valid. And it's also quite easy and straightforward to apply. Okay, the next rule we're going to consider, the rule of disjunction elimination, is a little bit more complicated. And I want to go ahead and introduce this rule by first looking at an example of an argument stated in English. Either a Democrat or a Republican will be elected. If a Democrat is elected, some people will be happy. If a Republican is elected, some people will be happy. Therefore, some people will be happy. Now, this argument is straightforwardly and self-evidently valid. It exemplifies the following argument pattern, P or Q. If P then R, if Q then R, therefore R. Or if we write this out as a sequent, it may be written as follows. As I said, this argument pattern is clearly valid. And the rule of disjunction elimination is based on the obvious validity of this argument pattern. It may be stated as follows. So this is the rule of disjunction elimination. If one has a sentence of the form A or B on a line, a sentence of the form if A then C on yet another line, and a sentence of the form if B then C on yet another line. One may write down a new line containing the sentence that corresponds to C. Alright, before I look at a couple of examples of this rule applied, I want to note that this way of formulating the rule is different than the way it's formulated in your book. And I want you to ignore what your book says about the formulation of this rule and do things the way I'm telling you to do them in this lecture. I have a couple of reasons for modifying the way in which this rule is stated. One is that I would like to go ahead and preserve the rule of conditional proof as our sole means of eliminating dependence on assumptions. And my way of formulating the rule of or elimination does that, but your book's way of formulating it does not. Another reason is that I actually think that my way of formulating the rule is much easier to understand and much easier to apply and to combine with our previous strategies for constructing proofs. But okay, let's go ahead and look at an example of the rule applied. So here is the sequent that I claimed is self-evidently valid. P or Q if P then R, if Q then R, therefore R. So we start out, as always, by writing down our premises. Now that we've got P or Q on one line, and the conditional if P then R on another line, and the conditional if Q then R on yet another line, the rule of disjunction elimination allows us to infer R. Because we have P or Q on line 1, and we have on line 2 a conditional that has one of the antecedents of the disjunction that we have on line 1 with R as the consequent. We have on line 3 another conditional that has the other disjunct of that disjunction as its antecedent and R as a consequent. Because we have all that, we are permitted via the rule of disjunction elimination to write down R. Okay, that's a straightforward example of the application of the rule of disjunction elimination. Let's look at a slightly more complicated example. So consider the sequent P or Q, therefore Q or P. Okay, we start out by writing down our premise. We have this disjunction. That's the only thing we have to work with here. So here is a strategy for using disjunctions in a proof. If one has a disjunction and one wants to infer a certain conclusion from that disjunction, one strategy is going to be to go ahead and try to prove a conditional that has one of the disjuncts of that disjunction as its antecedent and the conclusion that one wants to prove as its consequent. Then after one has done that, one's going to try to prove another conditional that has the other disjunct of that disjunction as its antecedent and the conclusion that one is trying to prove as its consequent. So my strategy here will be to attempt to prove the conditional if P, then Q or P, and then after I've proven that conditional, to prove the conditional if Q, then Q or P. And then once I have those two conditionals and this disjunction, I'll be able, via the rule of disjunction elimination, to infer Q or P. So that's my strategy. So let's do this one bit at a time. So my subsidiary goal right now is going to go ahead and prove the conditional if P, then Q or P. So since I want to prove a conditional, my strategy for proving conditionals tells me that I should go ahead and assume the antecedent and try to get the consequent. So I'm going to go ahead and do that. I'm going to assume P and then try to get Q or P. Well, now that I've got P, I can easily get Q or P via the rule of disjunction introduction. So I infer Q or P from P via disjunction introduction. And now remember, my subsidiary goal was to prove the conditional if P, then Q or P, and I'm in a position now to do that from lines 2 and 3 via the rule of conditional proof. Okay, now that I've accomplished my subsidiary goal of proving if P, then Q or P, I need to move on to my next goal. My next goal is going to be to prove the conditional if Q, then Q or P. So again, since I'm trying to prove a conditional, I'll start out by assuming its antecedent and then try to get the consequent. So I've got Q and I want to get Q or P. I can easily get Q or P from Q via the rule of disjunction introduction. Alright, now my goal was to get the conditional if Q, then Q or P. And I can get that now from lines 5 and 6 via the rule conditional proof. So now I have if Q, then Q or P on line 7. So now on line 1 I have the disjunction P or Q. On line 4 I have if P, then Q or P. On line 7 I have if Q, then Q or P. So if I take all those lines together, I am allowed to infer the disjunction Q or P via disjunction elimination. Alright, now that completes this proof and this example. I've given you some more problems to work on from your textbook, so go ahead and do that to practice applying these rules.